Sixth grade, Module 6, Lesson 4, Problem Set. Number 1, the following histogram summarizes the ages of the actresses whose performances have won in the Best Leading Actress category in the Annual Academy Awards. Alright, so A, at which age did intervals contain the most actresses? So which age interval contains the most actresses? How many actresses are represented at that interval? So the largest interval appears to be this one. That's the tallest. So that's between the ages of 24 and 32. So ages 24 to 32. And how many were there? Let's see. So it stops right there. So this is 30. This is 35, so it looks like there are 34 because it's pretty close to 35. So there are 34 actresses. In between that age who won Best Leading Actress. Describe the shape of the histogram. So the shape kind of looks like that. So it skews downward to the right. So I'm going to say that this is skewed right. It's definitely not symmetrical because it doesn't make a graph like that. So it's not symmetrical. It's skewed to the right. C, what does the histogram tell you about the ages of the actresses who won the Oscar for Best Actress? So it tells me, I would say, that most of them were between 24 and 48, or really 24 and 40. And then there were a few who won later on. So let's say most were between 24 and 40 with, let's see, there were two people down here. This person and then this person. It's either one or two people between 72 and 88. So there were a couple who won when they were much older. Let's see, two ages are much larger than the rest. Or much older than the rest. D, which interval describes the center of the ages of the actresses? So the center of the data, I would say, is probably about there, right in the middle, because there's a lot here and just a few there, but then there are, some going on down here. So it's not, I wouldn't say the center is between 24 and 32. I think the center is more around 32 to 40. And an age 72 would be included in which interval? So 72 would be included in 72 to 80. Number 2, the frequency table below shows the seating capacity for arenas for NBA basketball teams. Draw a histogram for the number of seats in the NBA arenas data. Use the histogram you have seen throughout this lesson to help you in the construction of your histogram. Okay, so we're going to make a histogram. And we're going to have frequency over here, so how often it happens. And then this is going to be the number of seats. So the frequency, the highest frequency is 6 and the lowest is 0. So we really only need to go from like 0 to 6. So that's 0, 6, 5, 4, 3, 2, 1. And then the number of seats ranges anywhere from 17,000 to 22,500. So I'm going to start out here and do the different intervals. So we're going to have 17,000 to 17,500. It's going to be hard to fit on here. Okay. So 17,000 to 17,500. And I'm going to go up in intervals 500 by 500 all the way to 22,500. So 18,000, 18,500, 19,000, 19,500, 20,000, 20,500. Gonna make it pretty long. 21,000. Okay. So we have all the intervals. Now, between 17,000 and 17,500, we had 2. The frequency was 2. So I'm going to go, there's 2. Between the next interval was 1. 18,000 to 18,500 was 6. So all the way up to 6. 18,500 and 19,000 is 5. 19,000 to 19,500. This one is also 5. 19,500 to 20,000 is another 5. 20,000 to 20,500 is 2. 20,500 to 21,000 is also 2. 21,000 to 21,500 was 0. The next one was 0, and then 22,000 to 22,500 was 1. So there is our histogram. Let's give it a title. NBA arena capacity. Okay, so we did A. What is the width of each interval? So the width of each interval was 500. How do we know? You can just subtract. You could do 17,500 minus 17,000 and you get 500. So it goes up, the intervals go up by 500 every time. We can subtract the values. That's how I know. All right. Describe the shape of the histogram. So the shape, I would say, looks kind of like that. So I would say that it's skewed more to the right because it slopes down a little bit slower that way. So I'm going to say it's skewed to the right. And what interval describes the center of the data? So the center of the data, I think this looks about to be the center of the data to me. Between 19,000 and 19,500. It looks like there's an equal amount on the left side and an equal amount on the right side. I'm going to go with that. 19,000 to 19,500 is the center. And it could vary, but make sure you pick either something in this range would probably be the center. Okay. Number 3, listed are the grams of carbohydrates in hamburgers at selected fast food restaurants. Complete the frequency table using the given intervals with a width of 5. Okay, so 20 to less than 25. Let's go through and count how many we see that are 20 to pretty much 24. Let's see, 20 to 24, I'm looking, there's 124. So just 1. So the frequency is 1. 25 to less than 30, so 25 to 29. I see 1. 20, so 2. 30 to 34. There's 1, 2, 3, 4, 4. 35 to less than 40, so 35 to 39. Let's see, any, so that's going to be a 0. 40 to 44, so 40, 1, 2, 3, 4, 5, 6, 6. 45 to 49. That will be 4. Let's see, 50 to 54. I see 2. 55 to 60. I don't see any. All we have left is 66. So that's going to be 0, 0, and then there's 1. That's 66. Draw a histogram of the carbohydrate data. Okay, so let's draw another histogram. So remember, this is frequency, and then we're going to have the number of carbs. So let's start with frequency. We have anything ranging from 0 to 6, so just like the last one. And then we have 20 to 25, 25 to 30, 30 to 35. So we're just going up by 5s all the way to 70. I'm going to start at 20. So 20, 25, 30, 35, 40, 45, 50, 55, 60, 65, 70. Okay, now we can draw our frequencies. So between 20 and 25 we had 1. So I'm going to go up to 1. 25 and 30 was 2. Then we have 4, 0 for 35 to 40, right? 6 for 40 to 45. I'm going to go all the way up to 6. And then 4. 50 to 55 was 2. None for 55 to 60, none for 60 to 65, and just 1 for 65 to 70. And let's give it a name. We're going to call it carbs, carbohydrates. Describe the center and shape of the histogram. So, let's see. The center, I would say, this looks to be about the center. Right there. So I would say the center is around 40 to 45, so anything in there. And then the shape, I would say it's pretty symmetric, right? So I'm going to call it, so let's say center is 40 to 45. Shape is approximately, and remember we say approximately because it's not exactly symmetric, so approximately symmetric. D, in the frequency table below, the intervals are changed. Using the carbohydrate data above, complete the frequency tables with intervals of width 10. So now we have from 20 to less than 30. So I'm just going to combine these two. So that would be 3. And then we have 20 to less than 40. So that would be 4. And combine these two. So that would be 10. We have 2. And then 1. So we're going to make a new histogram with this data. So this time our frequency ranges from 1 all the way up to 10. So I'm going to go by 2s. So 2, 4, 6, 8, 10. And then our intervals are just by 10s. So I'm going to start at 20 and go to 70. So 20, 30, 40, 50, 60, 70. And let's call this number of carbs. Your title, carbohydrates. So it's a similar graph, we're just combining some intervals here. So the frequency for the 20 to 30 was 3. We can go up to the middle of that. 30 to 40 was 4. 40 to 50 was 10. 50 to 60 was 2. And 60 to 70 is 1. So if we were to compare these two, they're showing the same data, just in different intervals. So you can see how they compare here. Okay, use the histograms you constructed in exercise 3 in parts B and E to answer the following questions. Why are there fewer bars in the histogram in part E than the histogram in part B? Well, we combined intervals, so we combined the data. So let's say A. We combined the intervals by making them larger. Let's say from 5 to 10. So it jumped from 5 to 10. B. Did the shape of the histogram in part E change from the shape of the histogram in part B? So looking at both of these, did the shape change? So I already drew the shape there. So here, I would say generally no, it didn't really change. It's still basically approximately symmetric. So I'm going to say no. Both are still, or not still, both are approximately symmetric. So the shape didn't change very much. Then what is C asking? Did your estimate of the center change from the histogram in part B to the histogram in part E? So what did we say? The center in B was 40 to 45. So the center here, I would say, is still, since these are a little bit larger over here, taller than these, I would still put the center more towards this way. So between 40 and 45. So I would say no, the center did not change. Let's see. No, the centers are still about the same.